Hello, and thank you very much for for giving the stage. Really nice to again speak to you here. Already have seen some familiar faces among the audience and the previous presenters. It's always nice to see you again, and hopefully then in the future also again in person when we move back to more physical events. So exactly over the next couple of minutes, I want to speak a little bit about not LiDAR-based vegetation management and monitoring, but satellite-based. I think it's another tool in the toolbox, and as with a lot of technologies, it has its capabilities and its limitations. And about this is exactly what I want to speak. So I've planned around 10 minutes of presentation, 10-15 minutes. Then I will give a short demo of our tool, and then I have enough time to answer also all your questions in regards to this new technology, and please feel free to ask anything from the basics to specific questions to the product. I will share my screen and we'll directly dive into it. So exactly. First, maybe a little bit about who we are as a company. As already mentioned, LiveEO is a company founded in 2018. We have now 70 employees with a global presence. Anthony Palizzi, who joined us recently as our director, utility sales North America. Some of you may know. And we are a partner of a lot of the satellite companies out there, because no, we don't own our own satellites, but we process data from a lot of the operators. And how that looks like, I will elaborate on in a second. Our goal at our company is to really focus on infrastructure grids globally, and we want to help the operators, so you to keep them operational. And that in an efficient way. We're speaking about electrical overhead lines, which is also the area where we have most of our clients, but we are also active in the pipeline sector, as well as in the railway sector, where we started off. So the first client, which we've worked with back in 2018, was the German railway operator, for which we analyzed around 20,000 miles of railway network regarding one thing, which is vegetation alongside its tracks. But this has not been the only customer or client which we've been working with, but over the now multiple years in operations, we've worked with grid operators all over the planet, which all have a similar problem, which is exactly vegetation. And we've done one thing which would be difficult with LiDAR, which is analyze the entire US transmission network. Now, LiDAR would be much more precise. I won't lie here, but I think the analysis of the entire US transmission network really gives, I think, very good example of what the great capabilities of satellite data are, which is to give you a snapshot over a big area of your network quickly and without having any kind of sensor in the air on the ground. But why are we capable of analyzing now the entire US transmission network, or grids of distribution and transmission grid operators, for example, in North America? Why is it possible now, right? Satellite data has been around not only since yesterday, but for decades. It's really because we have seen over the last, I would say, 10, 15 years, an increasing commercialization of the entire space sector, starting with companies such as SpaceX, which since the early 2000s developed rockets, which now, as they are in operation, have lowered significantly the price to get into space. And this has sparked a lot of developments in the area of satellite developments. And so there are a lot of new satellite companies which shoot satellites into space, and a lot of these satellites are Earth observation satellites. Now, there's a whole range of different types of satellites which are observing the ground from space, from the obvious meteorological satellites to optical satellites, which I speak today about, to also the more recent radar SAR satellites, which, for example, help to monitor the effects of storms and outages. But this is a different topic. We use all these different satellites for different use cases, including vegetation management, but also, for example, post-storm recovery work. But what's the general process? How do we translate petabytes of raw satellite data really into actionable insights? And it's a long process chain, as said, where we start from the raw data which we get from the operators. As said, we are working together with, for example, Airbus, with Maxa from the US, with Planet from the US, and other satellite operators from which we get imagery for a specific client. So let's say we work with utility A, and we started a project with utility A. We obviously define in which area we want to identify where vegetation is becoming a potential threat to the network, and we collect data from satellite operators. This raw data in itself is, I think, beautiful, and you definitely can print it out and put it on the wall, but it's not really actionable, right? As a vegetation manager, you would have to have the tedious work of look exactly at every picture, every pixel. Obviously, that wouldn't be practical at all. So what we do is we take this raw data and we, first of all, harmonize it, meaning that we co-registrate it and combine it with other data sources, mainly other satellite data sources, to create a unique kind of data stack, which has a high information depth. And I would speak about things such as resolution in a second. We then on there apply our artificial intelligence algorithms, which identify where vegetation is and where vegetation isn't present. We identify things such as vegetation height, and based on this information and, for example, catenary curve analyses which we perform, we automatically identify risk for different parts of the network. We then create actionable insights from there, for example, updates about specific spans, circuits, or feeders, and infuse this information either in your already existing GIS system or ERP system. But we also bring this information through mobile apps to end users in the field, your vegetation crews, vegetation crews in the field from your subcontractors, so that they really then in the end can take action where it's required. And so you get, in a short sentence, from satellite data an overview over your entire network and can pinpoint where actions are taken, or just plan and prioritize certain feeders over others if that's possible. In the end, in our perspective, that's the first step in the direction of condition-based maintenance. Now, as said, one of the use cases which we are doing is vegetation monitoring, which I will will speak in more extent in a second. Other ones are ground deformation analysis for pipelines and third-party monitoring for pipelines. Vegetation monitoring. Now, you have presentations, and obviously the LiDAR data already has been out there since a couple of years, and it's a very valuable tool for certain use cases and for certain users, right? It delivers you high resolution, but comes also with a price. So what can satellite data do? Satellite data allows you to analyze where vegetation is in 2D and 3D with lower resolution than with LiDAR. But it allows you also to monitor, for example, things as vegetation condition on a more frequent basis, right? So for example, on a sub-yearly basis, we can continuously monitor the development of vegetation, both in its extent in the different dimensions, as well as the changes of vitality, which can either be obviously caused by natural changes of seasons or by, for example, bugs and other infections. On top of these analytical kind of modules or segments, we then derive a risk analysis and prioritization. And this risk analysis and parameterization allows you to do encroachment identification, so identify where vegetation grows into the right-of-way, exactly close to the power lines from, for example, underneath or left and right from it. But as, for example, LiDAR has already helped you to identify it or other methods of ground control, what we are also able to analyze are, for example, fallen risk from trees from outside the right-of-way, which is, as we all know, is maybe the most important risk factor for the integrity of the network. So we're identifying where street too close to the network, too high. We identify or monitor whether there are any kind of outliers in terms of vitality, and can make a better judgment about who are the risk trees outside the right of way which want to be removed first. Can identify where dead trees are or where their morbidity is especially high, so potential danger trees again. And what also satellite data offers you is to identify remote auditing, not only of the activities of your own subcontractors, but also of people which have maybe properties around the right of way. And as we've seen with some grid operators, sometimes trim down, let's say, a certain plot of land or all trees on a certain plot of land, and let the last row standing, which obviously is definitely a risk in the case of a storm. But that being said, in the end, for us, analytics are, and you also heard a presentation, I think, earlier, which went in a similar direction, right? Data is only as useful as the tools with which you can then act upon this data. So the second point, which is really important for us, is, well, how do you take these insights which we derive from satellite data on large scale, and how do we infuse them in the work processes you already have? And we have two answers to this. One answer is, well, if you already have tools which you like and use on a daily basis, we integrate. Meaning that if you have an enterprise asset management system from one of the main vendors, such as SAP out there, and you're already working with their asset management and workforce management solution to prioritize and distribute work within your own work team and subcontractors, then we are able to integrate there into Hexagon /Infor, SAP, and others. Same is true for your GIS solution. So if you want to use your ArcGIS solution to consume these insights, we have integrations into these. But on the other side, obviously, not every utility is already fully equipped with these tools, and many still are using email and Excel files to prioritize and distribute work. And also here we as we believe have a good solution, which is our web and mobile app, which work in harmony, and the mobile works on Android and iOS. I will show you the web app in a second. What can be done with these tools, but as said also with the integration, is that you can we are automatically creating alerts and work orders from satellite data, that we every time we get a customer, we obviously adapt critical distances, risk parameters to the requirements of your utility, your regulatory framework, and your needs. And then all this information can then be distributed, for example, with our mobile app into the field. So again, to break it down, what I've said during the last round about 15 minutes, it really comes down to this 3-step process. We get an overview from space, we automate and create a span by span, for example, risk assessment, and we bring this to the end user, and through that increase the operational excellence. And now maybe to write the elephant in the room, what's the resolution of satellite data? And the first analysis, which I've mentioned at the very beginning of the entire US transmission network, that has been done on this 10-meter resolution data, because that's for free, right? So the data is for free, not the processing. That was pretty expensive, as you may know when you're working with data, but that was done on this. It was to show, hey, you can analyze really for nearly for more than 500,000 miles satellite data, and make a first assessment where you have areas which are vegetated or where not. The highest level of resolution which you can get from satellite data is round about 1 foot to 50 centimeters, right? This is the range. This data can help you, in our perspective, very well to identify exactly what are the risk areas on my distribution, on my transmission level, where I should focus my vegetation management activities on this year or this season. And this really can help you to get this overview quickly and cost effectively. But obviously, vegetation height is a factor which for use cases, for many use cases, plays an important role. So how are you able to identify from a 2D image 3D vegetation height? This is possible via two ways: either archived satellite data, which has already been previously captured, or via newly captured satellite data. And in both cases, what you do is you take two images from satellites being taken at a slight angle after one another. And from these two images, very much like your human eye and your human brain does it, we compute a digital surface model of the vegetation around your network. And again, that's something which we've done and just shipped to, for example, a client in Australia for 10,000 kilometers. So, right, 7,000, 6,000 miles. Analyzed completely in high resolution 3D with all the tools, with vitality monitoring, with risk analysis, with co-use analysis, with fire risk analysis. All these are things which can be derived from satellite data, but for which I just didn't have time to speak about. Now, in the end, what is in for you, and then I will come also to the demo. So reliability, safety, and a constraint. Reliability and safety can be improved, and exactly the data source in itself is and the analysis can be much more cost effective than LiDAR. So I want to take 5 minutes for a quick demo here. And what you see right here is an example of a transmission network here. Now, in this example, it is in Germany, but obviously transmission networks work very similarly all across the globe. And I think one of the previous speakers mentioned that, right, data integrity of our clients, super important. So this is publicly available data. So the network is publicly available. Yeah. So we don't expose any customer data here. Critical values are chosen by us. And also you as clients from North America, we host all our data in the United States. We process all our data in the United States if it's a customer. So the data doesn't leave the country, which is really important for us. But what do you see here? So this is the web interface, maybe used by a vegetation manager or the foreman of a crew, or maybe the manager of the subcontractor, to get an overview over, hey, what's the situation alongside the feeders, the span, the area in which I or my team now has to conduct some vegetation management activities. So let's zoom in a little. The blue line represents obviously the asset, in this case, the overhead line. And what we identify on the satellite images, which we automatically pull from the data operator, is where vegetation is present. And you see now here, obviously, in green represented vegetation alongside the overhead lines. And you see different shades of green. These different shades of green represent different height classes. So this 3D analysis of vegetation, for example, has a height resolution of around 3 feet. So we group vegetation height in different height classes, but the granularity goes higher than this. But with this kind of analysis, you can identify where you have high vegetation, where you have low vegetation, right? Here it's high, and here it's pretty low. Okay, we model the catenary curve of the overhead line to also get to know where you have a significant sag in the line and so on. But we also identify other vegetation parameters, such as, for example, vegetation species, which is possible if you have a certain set of training data on site, and other things, such as, for example, vegetation vitality, now not part of this demo. Okay, but I mean, that's cool. So you know where vegetation is, but does it really help you? No. You are interested in where's my asset, where's the overhead line, which we have to maintain, and for which reliability we have to we have to work. Where is this exposed to this external threat? And here it comes down right to the visualization I've shown previously. We are not identifying where vegetation is and the overhead line is. We are identifying where this overhead line is exposed to this external threat. This is now the red segment of the overhead line, and which part of vegetation are getting too close to the overhead line. Now, what you see here is undergrow, right? Now this is a transmission grid where this is possible. They don't have a clear cut in the right of way, but if you would now here have, for example, trees outside the right of way, which are high enough to fall into the overhead line, also the overhead line would be marked in red and would exactly show that it's exposed to this threat, and you would be able to pinpoint to the tree, which is or to the vegetation which is causing the threat. Now, okay, well, you have this now beautiful colored grid. What do you do with this? In my perspective, or in our perspective, that's still very much detached often from the operations which have to go on a daily basis. So what we've seen is that obviously utilities always work slightly different, but that there's a unifying, obviously, kind of terminology and use case in the entire asset management space, which is, okay, well, you have your assets, you have your errors, and you have tasks related to them. And what we're doing is we're creating tasks now, in this case, on a sub-span by sub-span basis. It could be on a span by span or feeder by feeder basis. We automatically prioritize these tasks based on the vegetation exposure of the asset. In this case, how high is the vegetation exposure of this part of the network? It's high because you have direct undergrowth from here, versus, for example, other areas where you have no risk because vegetation is low. That's why in this risk categorization, there's a distance of more than 20 meters between the overhead line, because it's also on the side of the close to the pole. So there's no danger here, right? So what can you do with this? You can assign this now to, for example, any kind of worker. Now, if you're the foreman, if you're the subcontractor, you could assign this to any crew, any team, or any person in the field. Now all these tasks have been assigned, and now let's say the team who's responsible for that area could say, well, where should I start? Let's start with the high priority, because let's imagine storm season is approaching early, or you want to go top down. Obviously, you have to batch because you have your mobilization costs, this utility, right, with your crews, with your bucket trucks. But let's say, okay, well, I want to know in which area do I have where do I have the highest priority? So, okay, from all these tasks, more than 100, I am now down to 10 tasks. Now I could say, well, because I have 3 high priority tasks alongside this feeder here, I start here. Now, on the mobile app on the other side, the person can go out into the field with the mobile app, could filter for their task, could add in information about property owner, and can plan protocols, complete protocols in the field about what they have done. For example, well, okay, this tree has been inspected and the tree needs to be removed. They can take pictures on site with the mobile app. And in the end, you then have a complete overview, top down, an overview of the entire network, as well as bottoms up from the people which are then on site. Exactly, yeah, you get this overview then as dashboard and on the map. You're gonna create as many users as you want. Maybe that's another interesting fact to know. You can filter for task, obviously, as said, important. So 10 important tasks, how many medium important tasks. And again, like an important thing I have to say is that everything from the critical distances, everything can be adjusted, and everything here has been analyzed can be analyzed remotely, right? Without any mobilization cost for the inspection. That's as much as I wanted to take time for the demonstration, because exactly, I think there's much more to talk about, and we would love to talk to you about this, especially Anthony, exactly, who's based out of Colorado, and who's exactly representing us in the US. Myself, I would love to speak to you, so please feel free to reach out. But I'm sure that there are a few questions. I see that there are 2 answers in the chat, but I can imagine that there are more questions, and I would love to answer them.
Thank you, Sven. So we do have some questions. The first one has to do with how accurate is this really? How do I, as a user of your system or customer, know that you are actually generating some really accurate data? How do you do your own validation?
Yeah, that's a great question, because exactly, I think validation and also giving the end user, the utility, a good feeling for the technology is super important, especially if you're looking at a fairly new technology. So it is a multi-stage process. Firstly, how do we validate the quality analysis of our technology, generally speaking? What we've done is we've done extensive ground validation campaigns for both the ML part, so identifying where vegetation is, how good that works, especially also on the spatial resolution, and also in terms of height analysis, how high is vegetation. We've done that on our end. But now, when we, for example, go to let's say Delaware, and would do an analysis in Delaware, right? How good can we say that our analysis has worked out for the utility in Delaware? For that, we are working, have again a two-stage process. On the one hand side, we have an extensive QA process, which we let run over the analysis before we ship it to the client. And then with the client, as part, for example, of a POC or a limited analysis of a certain part of the network, we have something which we call validation phase, where we onboard 2 users maybe, or 3 users of them on our tool, and create a random sample set of points where they can go out and validate whether the analysis which we have performed reflects reality, right? Because this, with machine learning and any kind of remote sensing technology, nothing beats the human on site who looks at your analysis and looks at the real world and then says how accurate it is. And so we've implemented this as a crucial part of our process. And with that, we both scientifically prove the capacity of our analysis, as well as really practically, which sometimes can be a very different thing, right? Yeah.
Now, is it a given that you need to use 1 meter resolution imagery for your work?
No, it's not a given, right? So we have distribution and transmission customers on both levels of the on the voltage scale, which are using 3 meter data, yeah, so 10 feet, and 1 meter data. It's a little bit a different kind of use case. For one, it's really like the identification of encroachments into the right of way, and with a low resolution data, it's more the identification of high risk areas, high exposure areas, for less granular but even more cost effective large scale identification of areas where you have to focus your work on, right? If you're a utility with tens of thousands of miles, maybe you don't have the budget to do extensive field inspection campaigns every year for the entire network, or you don't have the budget to fly a LiDAR for the entire network. Satellite data gives you the tool to also prioritize these kind of process steps. And this is, for example, also possible with this 3 meter data.
So on this next question, I suspect there's a lot of variables, but is there kind of an order of magnitude cost per mile or kilometer that you could talk about?
Yeah. So there's definitely a lot of kind of range, just because how often do you analyze something? Do you analyze it once per year or twice per year? Do you analyze it with a high resolution or low resolution? Do you monitor additionally vitality monitoring? Do you have vitality monitoring? Do you have species analyses, right? These are all different kind of building blocks which add up. But let's say it can start as low as something like $20 in the range of $20 per mile, right? You go with the kind of base option, and then can go as high as $100, $150 per mile. And another important thing here is the grid distribution, right? How dense is your network versus if you're really like in a rural area and have only a straight line which runs across the country, then obviously data cost is a little higher than if you are in a more suburban or urban network. So it comes down to the customer, but it's significantly cheaper than other measures. Exactly.
Now, can your customers download the satellite images?
So the thing is that the satellite operators exactly don't allow us to resell the data. So what we do is we provide the customer with the analysis which we perform, as well with a derived product of our analysis, which is a derived product of the satellite image, which very comes close to the satellite image, so that the customer also can see that. And like, for example, on a customer by customer basis, we can also come up with a framework where they get the data. So we have done that already in the past. It's definitely a way forward. It is just not the standard way to go. That always requires some discussion with the operators, but we are used to that and have done that successfully over the past multiple years. Yeah.
So we're a few minutes over, but I'm going to ask one more question, and that has to do with, do your customers typically only use what you provide, or do they typically integrate it with other forms of data collection as well?
Yeah.
And analysis.
Yeah. So I think like so what we've seen, so I mean, I believe that any kind of remote sensing technology always comes down to a funnel. You have a top funnel, which you can solve with a remote sensing technology, and you have a lower funnel, which you can only do with a trained arborist on site, right? Because they know what it really looks like, right? And so what we have seen with clients is that they use satellite data on the entire network, then they focus on certain parts of the network with LiDAR. In the end, it's always then the arborist on site, right? But yeah, it has been paired with other technologies. Yeah.
All right. Well, thank you very much to you. Thank you very much to all our speakers. I will add a final comment, because my background is in datums and projections, that you can't ignore that simple little phrase. I think it is just as valid a question with satellite-based data collection as it is with ground-based. So we do have our live session now. We'd like you all to stay on. And so, Anne, I'm going to turn it over to you.